ladies, happy Thursday. Today is February. And a huge shout out to girls basketball. An awesome victory last night over Bridgeland from the very beginning of the kickoff to the last minute or the last seconds of the game. Y'all were in control and you played together. Great teamwork, and also congratulations on being playoff bound. So good job, ladies. And also, students, just a reminder, the same thing we say every day. Remember to mask up with your mask appropriately over your nose. If you're not feeling well, let your teachers know so that way they can let the clinic know. And in the mornings when you wake up, make sure to self-assess. If you're not feeling well, stay home. But make it a great day. Wash and sanitize your hands, and also maintain appropriate distancing. And when you're in the commons, make sure that you scan in on the QR code. All right, so ladies, make it a great day.
Did y'all have a different substitute every day? Dang, there's like no substitutes out there. So good morning, guys. How are y'all doing?
We're good. How are you?
Good. I never got sick, so it was just like 8 days where I stayed home. I thought I was gonna like clean out the closets and get so much done. Instead, I think I binge watched like 4 seasons of Downton Abbey. I heard of that.
Yeah.
Yep. So it's pretty good. Anywho, so today was actually, I have a few things to talk about. Today was actually supposed to be our first test. So what I think I'm gonna do is just kind of, I've given you like 3 days of reviews pretty much, but I kind of want to go over it with you and maybe it just kind of talk about it and remind you about it. But don't freak out. I am going to go ahead and give you the test tomorrow, just so we can get that major grade in. But remember that there's always retakes. And I'm gonna go easy on you with the questions that I choose. Like there may be like 3 of the harder calculations, and so that'll be a difference between like an A and a B, which wouldn't be that big of a deal. Okay. So we are going to test tomorrow. Secondly, that egg drop project, you remember that. I'll go over that here in a bit, but we need to get that grade in. And so we can start building that on Monday, and then you can turn in your video as soon as you're done. Okay, so we'll do that Monday, and we can even talk about it a little bit tomorrow. So egg drop. And then the third thing that I need to talk about as well is first semester recovery. So if you failed the first semester and you need to remake that up, like if you failed with like a 66 or a 67, I don't think anyone failed with the 68, but if you failed with like a 65, 66, 67, I mean, even a 64, technically you could just make like a 75 from here on out and then bridge. Okay, so if you failed with kind of like a high 60, then I would just try and make sure that what you pass with at least a C, like a 75, and then you can bridge it. Okay, if you made like a 63 and below, 50 or 40 or 30 or whatever, because you just kind of stopped coming to class, or you couldn't wake up early enough, or whatever, for whatever reason, I'm gonna have like a whole bunch of practices, like little practice quizzes that you can take and practice, and then I'm going to have like it's essentially like a final. And so you are going to take that final, and whatever you make on that final, up to a 70, I'll change your second semester grade to. Okay. So if you're interested in recovering for that second, or for that first semester, the whole first semester, just send me a message and let me know, so that I can start assigning you those quizzes and those practices, and to get you ready for like a final that you take on your own time. Okay. Okay. But send me the message, because sometimes when you tell me verbally, I start doing too many things and then I forget what I'm doing. Okay. All right, so those three things were kind of the most important, because I have counselors and stuff emailing me about students, and I'm like, well, I'm not back in the classroom yet, and I didn't want to give it to you over like when I was at home, because sometimes when my messages or instructions get too wordy, not everyone makes it all the way down to the last paragraph, right? I think like they'll stop reading or something, or you don't read them at all. I don't know. Okay. So I'm just going to kind of go over what we learned in the whole momentum unit. So I'll post these notes in Schoology so that you'll have them. And then anything that we did this past week, like Monday, Tuesday, and Wednesday, is good review material for tomorrow's test. Okay. And I'm more than likely not going to take any of that for grade. So just practice. All right, so let's start with a few notes. And so you can write this down with me if you want, or you can just kind of watch. All right. Sometimes I think it's helpful to write it down though, because even just writing it once, stay in your head. Okay. Now I just have to everything more. Nope. I'm looking for my Promethean pen. All right. So we first learned what momentum is. And so remember, momentum is mass in motion. Right? And so one thing that you kind of see in some of those multiple choice questions that I've been showing you, like the exit tickets, which the exit tickets that I made for like the past 8 days were all taken from momentum tests that I've given in the past. Okay. So that's also another good place to go back and kind of look back at those questions. Mass and motion. And so remember that momentum depends on two things, one being mass, and then the other one being velocity, right? And it's not just, sometimes you'll see mass being addressed as inertia, and it's not just inertia, because inertia is just the tendency of an object to keep doing what it's already doing. But that inertia also means staying completely still. And if your momentum, if an object has momentum, then it has to be moving. And if an object is not moving, then it has zero momentum. So sometimes inertia only has to do with mass, not velocity. They kind of address mass as inertia. Okay, and then remember that it's P is momentum and it's mass times velocity. So that's my formula. And then the unit kg ms. Okay, and so we had questions like, which has more momentum, a slow moving feather or a parked truck? Which one has more momentum? Oh man, okay. Yeah, the slow moving feather is going to have more momentum because it's actually moving, and the parked truck has zero momentum. And then we talked about things like, what happens to my momentum if my mass increases? If my mass increases, my momentum, because remember, you're thinking of momentum as how difficult it is to stop something. So the more difficult it is to stop it, then the more momentum that it's going to have. So if your mass increases, then your momentum increases. Right? If your mass decreases, then your momentum, yeah. It has that same relationship with velocity as well. If you're going faster, then your momentum does what? And the opposite, if you're going slower, if you slow down, your velocity decreases, your momentum, yeah. And so you also got questions like, if let's say a rock is free falling towards Earth. If a rock free falls to Earth, what's happening to its momentum as it falls? It gets faster, so its momentum increases. So those are the kind of questions that you're going to see that just talk about the basics of momentum, and then like very simple ones like, oh, the mass is 3 kilograms, the velocity is 6 meters per second, what's the momentum? Right? So where you're just calculating it. So that was when we talked about like the basics of momentum. And then we went into, oh, that was at the last slide. I don't know why I can't see. Hi, Miss Diane. Good morning. Oh, I'm doing good. Yeah, I stayed good the whole time. Got lucky. Yeah, so lucky. Yeah. Yeah. Thank you. Yeah, me too. Okay, thank you. Hi. Everyone's coming to visit. I'm back. Yeah. Okay, sorry about that. I know they were desperate for subs. I think that one Friday I was on, there was like 18 teacher positions where they had no sub. Okay, so then we talked about the change in momentum. And so how do you get something to change its momentum? Well, how do you cause, well, no, that's not the question. In what ways can an object change its momentum? Right, so slow, speed up, coming to a stop is slowing down, and then changing direction. And the biggest thing from this part was was calculating the change in momentum. And remember, calculating the change in momentum was just, you have one momentum and then you have a second momentum, right? Because the object is going this speed and then it's going to go a second speed. And when it gets to that second speed, well, it's momentum changed. And so how do you find that change in momentum? And remember, that's when we did, we figured that it's just the difference. But the one key thing being that the change in momentum, it's always your final one minus the initial one, right? And then right before I left, I showed you one other way to do it. I told you that you could technically subtract the velocities first and then multiply by the mass. So it was mass times the change in velocity. Where this change in velocity right here, as long as you did final velocity minus initial, then you would get the same answer. So you might see a couple of calculations on calculating the change in momentum. What else? The other thing that you might see is graphs, and I think there was a couple of problems like on that Google form practice that I gave you. Oh, and the circuit one that I gave you. It had like a VT graph, right? And so it had, maybe it had a velocity of 10, and then it went to a velocity of 0 in like 5 seconds. And then it said, what's the change in momentum? Right? And so when you're solving for something like this, remember the important part is to actually pay attention to what kind of graph you have. Because in this one, it gives you, let's see, what is the change in momentum if mass is 2 kilograms? Right? Well, it's going to have an initial momentum right here, which is just mass times velocity. Mass is 2, velocity is 10. Initial momentum was 20. And then it's going to have a different momentum here, but it's at 0. So its final momentum is just 0. So what is the change? Final minus initial. Okay, that graph one would probably be a little bit of a harder one. If I give you a graph one, it'll be like just 1. That's pretty much it. And then we went into what causes a change in momentum. I was still here when I taught you this. What causes the change, or how do you physically get something to change its momentum? Yeah, so how do you, like, what would you do? How do you slow down? The brake. And so the brake is doing what to your car? How? Huh? Yeah. That's when we learned that if you want to get something to change its momentum, you apply a force over a certain amount of time. That force applied over time is called the impulse. And so we learned about impulse. So there was impulse. Hopefully this is somewhat of a review, right? And this is a force. The impulse applied. No, let's just do it straight. The impulse. Force applied over time. And it was J. And it was force times time. Okay? And so very simple calculations. What is the impulse of 10 Newton force for 5 seconds? What is the impulse? Force times time. 50 Newton seconds. Oh, there's the unit. Okay. Couple of those. Then we learned that the impulse applied causes a change in momentum. Right? So impulse is equal to change in momentum. They're the same number always. Always, 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 okay? So if you calculate the impulse, that's also the change in momentum. They're equal to each other. Impulse equals change in momentum. Okay, they're the same number. So like here, if my impulse is 50, then my change in momentum is also 50. Okay, those are always going to be the same number. If so, where you're going to find that become a little bit more difficult will be like, if I give you a question where I say, the object changes its velocity from 0 meters per second to 5 meters per second. What is the impulse? Right? The technically 2 kilogram object. Let's give it a mass. And so instinctually, you'll be like, well, these are my formulas. And then you'll be like, but what's the impulse? That's force and time. And so you'll be like, well, I don't have force and I don't have time. How do I do this? But you have to be able to remember that my impulse is equal to my change in momentum. So while you don't have the force and time, you do have everything that you need to calculate your change in momentum, right? Because the object was going 0 and then it's going 5 meters per second. So you can find the change in momentum here. So you can find the impulse by finding the change in momentum because those numbers are always the same. Okay? Okay. Last thing we learned. Collision. Okay, the big takeaway from collisions, because I wasn't here for any of this part. I tried to make videos. Hopefully they weren't too confusing. The biggest thing from collisions is the momentum before the collision is equal to the total momentum after the collision. So it's like the energy of the system, the momentum of the system is conserved. So when collisions occur, it just one momentum will completely go into the second car, right? Like the momentum just transfers from one car to the other. So the key thing, and this is called the law of conservation of momentum. The key thing is the total momentum before equals the total okay? None of the momentum is lost. New momentum isn't gained. It's just transferred from one object to the other. And because of that, you can set those two equal to each other, right? So basically it's like if a car hits, no. If a car crashes into a parked a truck, right? So this is going 0 meters per second, and this one crashes into that one going 10 meters per second, right? Uh-oh, I hit something. right? Remember when you did those collisions and then they collide, right? And so what happens, right, if they bounced apart? Like what happened on that lab that we did? If they didn't stick together? Yeah, all the momentum either transfers to the truck and the truck goes off and then the car stops, or they stick together and they move away. But since they got bigger in mass, they move away slower, right? So either the car stays still and then the truck moves off, kind of like on the lab. They showed you both scenarios where that can happen. Like it just totally transfers all of its momentum over and the car stops, or they stick together and then they move away together, but it's at a slower speed because the mass increased, right? Because it's like they move together as one. And so if those collision calculations were difficult, I don't want you to spend your time trying to figure it out, because I'm only going to put like one or on the test. And if there's only one, then don't waste your time. Just miss the 4 points and study the other things. Study like the conceptual, right? I know that the total momentum before is equals the total momentum after. I know that the total momentum of the system stays the same because nothing is lost. Like, keep in mind those things. Okay, because that's going to be, there's more questions on the conceptual than there I'm going to put on the calculation part of this. The other ones that we did were like the cannons. There was, or there can be rifle questions, but there's like a cannon and then there's the cannonball in there, right? And then it fires. So technically this is before, and then it fires the cannon out. Let's say it's 10 kilograms, and then this one's like, I don't know, 300 kilograms. But that recoil velocity is basically like the kickback, right? Because whenever something goes, it's like the third law, right? For every action, there's an equal and opposite reaction, which technically for every force, there's an equal and opposite force in the other direction. So when that cannon goes forward, when the cannonball goes forward, the cannon kicks back. There's like a whole bunch of like videos that you can see of people getting hurt when they're like shooting a firearm because they hold it wrong. And when that kickback happens, it like knocks them out, right? Because third law, it's going to kick back. So it always asks you for this recoil velocity, that speed at which that cannon kicks back. But you know that when something happens like that, what's the total momentum before the collision? Because this is technically the before. 0. And so if the total momentum before the collision is 0, what is the total momentum going to be after the collision? Huh? 0. Yeah. So whatever's going to happen is this, right? This momentum would be like 500 times 10, 5,000, and whatever this one is going to be, whatever it is, it's going to equal out to negative 5,000 because it's going to the left. And so if you were to calculate it out, it's just going to come up to 0 because negative 5,000 plus 5,000 is 0. So just remembering that total momentum before is total momentum after. And if it stops completely in the before or the after, that means that even, on the before or the after, it's going to be equal to 0 as well. Okay? That's pretty much the unit. Sorry, I didn't need to talk for that long. It was kind of a long unit. But if those calculation collision problems like confuse you, don't dwell on it, but focus on the conceptual, right? Total momentum is conserved, it's not lost. Yeah. focus on the conceptual. There's more conceptual on the tests than there are any of the calculations. And I'm gonna do more of the easier calculations, right? The ones that are like solve for impulse, solve for momentum. Okay, all right. Oh, what about their momentum? Oh, sorry, I just saw your question. So I would recommend, let me keep that, save that. Is just going back and doing those Kahoots and those reviews from yesterday. I can post a key of that study buddy I gave you. I don't know if I gave it the day before I gave it to you. Question: did my quizzes link work yesterday? I didn't think it would. You know, I got to like 2 p.m. and I was like, you know, I'm supposed to assign that. Like I'm supposed to make my own special link. And I think I just
They didn't work.
yeah, okay, I can fix that. So I'll go ahead and post that. I'll post my notes. I'll post that Quizlet and just continue reviewing. The things for last week, I still haven't graded your drawing from that Friday way before. That's going to be a pretty simple grade if you did it, 100. If you didn't, a 0. And then I'll probably offer some kind of like next week, some kind of like if you didn't do something, some kind of recovery, like this will replace a grade. And then for last week, I'm definitely grading the lab. And I'm definitely going to grade probably that video lesson that I did, maybe those last few collision problems, just to see if you completed it, okay? But I think that was the, if I look back, and I'll write this down too, if you're missing it. I think it's like the 27th was the lab, and the 28th was, I think, my video lessons. Yeah, those. I think those are gonna be my 2 grades for last week, okay? Do y'all have any questions?
You said last week assignments are for a grade, and this week it's not gonna be.
So not all of last week's. I'm only grading the 27th and the 28th. So the 27th and the 28th. So just
Okay,
make sure you have those
sounds
2
good.
dates completed.
Yes, ma'am.
Okay, so we have roughly 7 plus 13, 20 minutes left. So you can kind of make sure that you've finished that. I haven't even looked to see who's completed those labs or those lessons. You can review and I'll repost that Quizlet. Like I can do that now. And if you have any questions, just let me know, okay?
No assignments today?
I'm just gonna repost the Quizlet. So just review and make sure you're ready.
Okay, thank you. You have a good day.
Yeah, you're welcome.
Yes, ma'am.
Please, did you take attendance yet?
right, guys, y'all have a really good rest of the day. I'll see y'all tomorrow.